Still talking about equivalent forms, but it's expansion. So what we're going to be learning is called the binomial theorem and Pascal's triangle. Okay. So binomial theorem is basically when you are using your binomial expression. So a binomial expression just means that you have two things that are being added together, correct? That's a binomial expression. Two things that are being added together. And it's an expression because I'm not saying it's equal to anything or whatsoever, okay? When n is a positive integer, the pattern is known as Pascal's triangle. Pascal's triangle is just a shortcut of, do you guys remember FOIL? I don't know what FOIL is, or multiple distribution. It is a shortcut to essentially doing multiplication of binomials when your power is high, okay? And so we're going to be using what's called Pascal's triangle, okay? It's interesting. You can look it up, but just to dive a little deeper, we're not going to. So to start off with, we're going to talk about the definition of a binomial coefficient. So the expression, if we have n above r. So n above r is what this means. So when you see this, this means n above r. It's called a binomial coefficient. How do you find your n above r? This is not an excited n, okay? This is, I just had a brain fart. Factorial. A factorial, n factorial, okay? It is not an excited n. It means that whatever the value of n is, you're taking all the integers that are less than it, positive integers, and you're multiplying them together. So if this was 5 factorial, it would be 5 times 4 times 3 times 2 times 1. If it was 6 factorial, that means you're doing 6 times 5 times 4 times 3 times 2 times 1, okay? It is not an excited number. It is called a factorial, okay? What does it say right here? You do not need to know it. It is just a shortcut. Does that make sense? So there's other ways of doing it. You do not have to remember this formula. If you do, great. If not, the main thing is remembering Pascal's triangle, okay? All right, so let's dive in. Now, I think this is like a fun little thing. It's a little brain break in my mind because it's a logic puzzle, essentially. You may not feel the same, and I'm okay with that. All right, so up first. So here we have our first binomial, and it says 6. How do I read that again? How do I say we read it? 6 above, right? Sorry, where'd it go? So n above r, okay? N above r. So this would be 6 above 2, right? So when I read this, what it's telling me is I'm going to write this in an expanded form. So writing this in its expanded form, this equals your n, which is your 6. So 6 factorial over 2 factorial, and it's times their difference factorial. So the difference between 6 and 2 is 4. 4 factorial. How do we feel about the setup? Was that terrible? Okay, let's try it again. N above R, so 9 above 4, right? So this means mathematically, I have 9 factorial over 4 factorial, and their difference is 5 factorial. Okay? Here, we have 3 above 3, which is 3 factorial over 3 factorial, which makes this 0 factorial. Okay? It's not bad. All right, now let's actually find the answers. How do we feel about the setup? Setup's good? We're chilling? We're chilling? We're okay? No one's mad at me? Okay. I said mad about me. All right, so when you are setting this up, essentially, it's easy. The next thing is reducing it, okay? When you have common factors in the numerator and denominator, what do you get to do with those common factors? Eliminate, right? If I have a common factor in the numerator and a common factor in the denominator, I get to eliminate them, okay? Our job is to try to eliminate. So when you see this 6 factorial means I have 6 times 5, and I'm going to leave it at 4 factorial. Why am I going to leave it at 4 factorial? Because in my denominator, what do I have? 4 factorial. What can I do with that? I can cancel it out. I can eliminate. And now I'm just left with basic multiplication. What, 6 times 5? 30. And 2 factorial means you have 2 times 1, which is what? 2. So this equals what? 15. Okay. I'll do it again. No one wants you to actually multiply 6 times 5 times 4 times 3 times 2 times 1. That's not the goal. The goal is to be able to reduce and then use smaller numbers to multiply, okay? So what you're going to look at is what's in my denominator. What can I eliminate in my denominator, right? I can eliminate 4 factorial, right? That means I need to somehow get 6 pi to be written as something with 4 pi. 6 factorial. 6 factorial means I have 6 times 5 times 4 times 3 times 2 times 1. I'm going to write out the 6 times 5, but once I get to the 4, I'm just going to write 4 factorial because that means 4 times 3 times 2 times 1. Now I have it in the numerator and I have it in the denominator, so I can eliminate it. Okay. After I eliminate it, I now have 6 times 5, which is 30, and I have 2 factorial. 2 factorial just means 2 times 1, which is what? 2. So I have 2 times, oh, I don't know, my pen. I didn't do that. It did it so. One day I'll buy a more expensive board, but until then, y'all are going to deal with this. 30 divided by 2 is 15. So the answer is 15. Okay. All right, let's try it again. Ready? All right. So now again, our goal is to be able to eliminate, right? So when I look at 9 factorial, I want to try to get rid of 5 factorial or 4. Always try to get rid of your largest, right? So 9 can expand to become 9, 8, 7, 6, and then 5 factorial. Does that make sense? Because I would just keep going. I did not give my yes. And then in the denominator, I would have 4 factorial and 5 factorial. What happens to my 5? It goes away. Huh? Yeah. So it wouldn't be point of writing it. Keep writing it. No? Okay. No. Let's see. I think if I write it bigger, I think that'll help. I feel like y'all think I'm playing. I'm being serious. Okay, let me go to a blank page. All right. So here we go. If we're at 9 above 4, which we agree setup would be, I don't know why I did that. And then their difference was 5. What the heck? I don't know. It's making, okay, we're just gonna roll with it for the sake of time. All right. So were we good with the setup? Okay. Your n factorial, your r factorial, the difference of them factorial, correct? Now, what 9 factorial means is that I have 9 times 8 times 7 times 6 times 5, dot. But I can stop at 5 because in my denominator, I also have 5, right? So I can expand on the 4. 4 times 3 times 2 times 1, but I'm going to stop at the 5 because therefore I can eliminate those 2 factorials. They're factors. I have the same factors in the numerator as in the denominator. Okay, so now I've eliminated them. Factorial just means I'm not really an excited number. I'm just a number that's over multiplied. Okay. Now, when you're all at this point, it's just a game of multiplication and reducing. Okay. So these are all the numbers that I'm left with, and I'm going to reduce them. So you have the choice to multiply and have big numbers or reduce and have smaller numbers. Does that make sense? So like 9 can be reduced by using the 3, correct? I can divide 9 by 3, and this becomes a 3. Are you with me? I can divide 8 by 4, and this becomes a 2. I can't do anything with 7, but I can divide 6 by 2, and this becomes a 3. And so all I have left to multiply to find my answer is 3 times 2 times 7 times 3. And that is my answer. So we are 6 times 21, which equals 126. Okay? Yay? Did seeing it bigger and expanded help? I know y'all thought I was being funny when I said I need to write it bigger, but I meant it. I meant I needed to write it bigger. Okay? But that's what it is. So again, factorial just means you are multiplying every number that is all positive integers that are less than that value. But do you really want to multiply 10 numbers? No. So you want to use your number sense to try to reduce before you have to multiply. Yes? And so we reduce before we multiply. And then we multiply. And this is way easier to multiply this than having to do 9 times 8 times 7 times 6 times 4 times 5. No, it's not part of college algebra. Okay? But does that make sense? Yay, nay, maybe so? Did that help?
Yeah.
You can tell me if it did it.
Okay. What if you don't reduce it and you just like multiply it on?
Then that's your choice. If you choose not to reduce, it will still give you the same answer, but you would be multiplying 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That would be your numerator. Then you would have to go in the denominator and do 4 times 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. And then that will be your denominator. Non. They're equivalent. That's why this is called equivalent forms. So the goal, because this wouldn't be on a calculator part, you'd have to be strong at multiplying and fast at it. Okay? Which is why we go over the number strategies to reduce. Does that make sense?
Sure.
Okay? All right. You know what? I'm going to give y'all what to do. It's not in your notes, but I want you to try it. It's not in your notes, but you're going to do it to see how it goes. Yes, to make sure that you really understand what we did. All right, here you go. Try it. 8 above 3.